Students participating in the Glenbrook South High School PLCW Digital Electronics class teamed up with Belden, a manufacturing company based out of Chicago. The school was lent a robotic arm where students would learn about using basic commands. It involves the use of a small screen called a teach pendant. The pendant will be able to control all of the movements by programming commands that are entered. Before the project started, a flowchart was created by teacher Justin Zumo, who proposed ideas of what the robot arm would do. However, as a result of shortened time, many of the initial ideas that he had needed to be rethought. Here's how it works. First, the customer will place their card that they would like to scan on a small table. A camera will snap a photo of the card, and the image taken will then be displayed on a TV monitor. After that, the robot would return the card to the customer. The customer will then create the subassembly by placing it into a piece of laminate and then putting it into a carrier. They will then place a subassembly on a conveyor belt on the indicated area. To start the conveyor, the customer will press a button, and it will then be taken by the robotic arm. The robot will deliver the subassembly to the laminator. After the card passes through, the subassembly will be pulled out of the laminator by the robotic arm. Then, it will be placed on a second conveyor belt, which allows the card to be transported back to the customer, along with allowing the laminate to cool. Along the way, a sensor will be broken, which will make the robot grab the subassembly off the end of the conveyor and hand it back to the customer. Finally, the customer will remove the product from the carrier and add the loop to it manually.
Can you explain what your role is in this project?
So my role in the project was to come up with gripper ideas for the robotic arm so that it can hold the carrier and the cards.
The old grip was very square and I went out, but it did not function pretty close to be able to grab the card. So we needed to redesign a new way of grabbing the card and moving it to the areas.
So my group manufactured the stand so that the camera can scan the card in between.
We're on the graphics team, so we're in charge of making graphics for the robots, cutting signs and stuff to promote the company.
I'm part of the media team where I will be showcasing this project to everybody.
I did the flow chart, which basically showed what the robot does and kind of step by step.
I'm doing all the TV stuff, I'm doing all the pneumatic stuff, which is what I'm working on right now. Currently, I'm in the TV group, but I'm kind of working all around, just helping everybody wherever they need it.
Can you explain what you are working on as part of this role?
So my design was basically aesthetic, and we used Onshape to make our own design. Each member of our group did a different one. I went for one that reminds me of a needle-nose plier.
We essentially decided that manufacturing it on Onshape, and so we designed it on there, and the legs we already had, and then we laser cut the acrylic so that it fit the proportions and sizes we needed.
Last class we made some stickers, so that was pretty fun. In this class we're gonna make some vinyls to put on the robot and probably plan what else we're gonna do in terms of making signs and stuff, and that might be a little hard to do this class.
So right now I'm currently a commentator who will actually help to present what is going on in a certain part of the video. So I will also be making a description of what happens in a certain area along with the history of the actual project.
I just basically made a Google Slides with the flowchart, and then I basically had to just add pictures to it and kind of describe each of the steps.
What tools, materials, or programs were you using for your role?
So we used Onshape to design it, which is a 3D modeling and CAD website. We also had them printed out, and I think that's about it.
So we used Autodesk Inventor, which is what we used for freshman year, and then some of us used Onshape.
We're using Adobe Illustrator.
And then what do you do on Adobe Illustrator?
So basically, for stickers, you download an image and do some stuff, cut it out, and send it to our vinyl printer, and then that takes the image from the file and makes a little sticker.
This is a pneumatic air compressor. This basically just has a cutting distance, so it's really fast, it's really good at cutting metal quickly.
What is your favorite part about working on this section of the project?
We all got to
use our own designs, and they'll all be like showcased, which is really cool because we all put time and effort into it.
My personal favorite is working with my group to measure the original grip tool and putting dimensions in, working together to create a replica of the grip into Autodesk so I can recreate it and make it different.
I think it's just the cooperation. That was really nice. Just solving the problem and finding a solution.
I'm really excited to be using Adobe Illustrator again because we haven't been able to do that since freshman year.
By working on this project, I feel like I'm actually cooperating with a major company that we affiliate with, and as a result of that, I feel like I'm making a huge impact on the world.
I think it's kind of cool how like I could kind of bring it to life. And instead of like it just being, you know, a bunch of steps, it's kind of like a way of graphically representing kind of what happens.
My favorite part about working on it is using the robotic arm. It's something we don't get to do every day.
Mr. Zuba, can you talk about how the arm works?
So the robotic arm is programmed using the same kind of methods that we would use to program our VEX robotics. It's a lot of if statements, if a switch is on or if a command is true, move to a waypoint, make sure the arm is moving, open and close the gripper, that type of stuff. So all of it is actually programmed using a touchscreen command module. You actually program all of that right onto there, and then that program will interact with a separate set of software that's running the separate program to actually control all the switches, conveyor belts, and everything else that we have going on with this project.
Can you explain how the students are contributing to this project?
Students are contributing to this project in several different ways. In fact, we started working on this at the very beginning of August, and we had students join us from engineering club, and they were coming in once or twice a week to kind of work on the project, do a lot of brainstorming, a lot of the front end work. And then when school started, I actually brought the project into my classroom for my digital electronics class. And so students just kind of divided up and took on different roles. We had a media team, we had a graphics team, we had a team that was doing 3D printing, a team that was doing laser cutting. And so everybody found a different area of the project to work on. So it ended up being a really great experience for the classroom as well.
What's the most rewarding part of working with students on this project?
The most rewarding part of working with students on this project is the fact that we're blending what we already know with our educational robotics and taking this into the real world and messing around and using and programming industrial robotics. So I think that for me is the most rewarding part, just knowing that I'm bringing this next level opportunity to our students.
Do you think that you'll ever do a project like this again in the future?
I would love to do more projects like this in the future. It's been great partnering with the different businesses, and they kind of give us a different perspective on different tools and processes that we could be sharing with our students. So I would absolutely do this again.